The speed limit on a particular highway is marked 65 miles an hour. However, as we all know, not all cars drive at that speed. The speed that cars travel at would be approximately normally distributed. Let's say that the mean speed on the highway is 70 miles an hour, and that's also the most probable speed for a car to be traveling. Some people drive above that speed, and some drive below it. The figure below shows a continuous probability distribution for the speeds that people are driving. According to the distribution, what is more probable? A randomly selected car driving at 60 miles an hour or driving at 50 miles an hour? So in these types of continuous probability distribution diagrams, the height of the curve off the axis tells us about the relative likelihood of these speeds being chosen. The higher the curve, the more likely an outcome is. So 60 miles an hour is more likely than 50. What is the probability that a randomly selected car is driving above the mean of 70 miles an hour? Well, by symmetry of the normal curve, we can see that half of the area lies above the mean. And half of the area lies below it. So with that in mind, 50% is the answer to this question. Half of the cars will be driving above the mean, and half of them will be driving below the mean. What's more probable? A randomly selected car driving 50 to 60 miles an hour, or a car driving 70 to 80 miles an hour? Here we can use the areas under the curve to tell us about the likelihood of these events. So for 50 to 60, we want to examine that area, but for 70 to 80, we want this area here. Which one looks more probable? The larger the area, the more likely the outcome. So 70 to 80 is actually more likely. As we've seen in the past, the standard deviation is a measure of how spread out the data is. Let's assume that the standard deviation of the car's speeds is 10 miles an hour. To write that in mathematical language, we'll use the little sigma, which is a Greek letter, which stands for standard deviation, and we'll say it's 10 miles per hour. That tells us about the wideness of the curve. If a car is driving 80 miles an hour, how many standard deviations is that car driving above the mean? The mean is the peak of the curve, so the mean is 70. So this car would be 10 miles an hour above the mean. But the standard deviation is 10 miles an hour. So they are one standard deviation above the mean. Now in statistics, there's a letter that we give to this, and it is Z. It's called a Z-score, the number of standard deviations above the mean. If a car is driving 70 miles an hour, how many standard deviations is that car driving above the mean? Well, that's almost like a trick question. If the mean is 70 and they're driving 70, then they're driving 0 standard deviations above the mean. They're at the mean. If a car were driving 60 miles an hour, how many standard deviations is that above the mean? Well, that's a little tricky question as well. They're not above the mean, they're below the mean. So the number that we're going to give to this will be a -1. Z equals -1. Or in other words, 1 standard deviation below the mean. If a car is driving 90 miles an hour, how many standard deviations is that car going above the mean? The Z for this would be 2. 2 standard deviations above the mean. Now let's say hypothetically that in an effort to get drivers to stay closer to the posted speed limit, police decide to write tickets for both speeding and for driving too slowly on the highway. What they're going to do here is squeeze the curve and make it narrower and taller as well. How has the mean of the vehicle's speeds changed according to the picture you see? And how has the standard deviation changed? Well, we see that the peak is no longer at 70, it's now at 65. So the population mean went from 70 down to 65. And also, sigma has changed as well, whereas before the width between these markings was 10. Now the width between those markings is only 5. So the sigma went from 10 miles per hour down to 5 miles per hour. And this just makes a narrower curve. With the normal curves, we like to show the markings of 1 standard deviation above the mean, 2 standard deviations above the mean. We also like to show 1 standard deviation below and 2 standard deviations below. So that's something we can use to gauge about how big the standard deviations are.